Yeah.
Okay. So we are live on YouTube. So we will be first calling the team ID 277 IIA 0277 FusionX Deepfake Image Detection with GPU Accelerated Distributed Learning. So we can admit that. Hi team. Good morning.
Uh, just a second. It's, I guess, yes, yes, yes.
There is a echo coming in.
So there's an echo.
Before we start giving you a idea, we will be like already communicated. You will be having 12 minutes to present the project. Warning will be given to you at 10 minutes. There will be a chat saying that 2 minutes are remaining. Please try to
Okay.
wrap it up in 10 to 12 minutes. After that, the Q&A session will be open to the jury. We have
Yes.
Varkis Cherian, Head of Technology Services at USG, and Sadish Babu, co-founder and past president of INAP, joining here as the jury members. So, if you are all set to go start,
Yes.
you can, yeah, please, you can start the presentation and you can go ahead. Thank you. All the best.
Yes. Thank you. So, good morning to the jury and myself, Varun Patki. This is Durgesh Sonar, and Adish Pawar is also here. And yes, Adish has started the PPT. So I would first like to tell that what is the significance of deepfakes. Next slide, Adish. So deepfakes are AI generated material, and those images. Uh, there's an audio coming here. So AI generated images are deepfakes, and as we can see here that Adi's slide was not Adish's slide. The deepfakes incidents have increased at a remarkable rate since 2023. And there are several incidents, like the recent one is that the Bangalore residents duped of rupees 95 lakhs by deepfake videos of Narayan Murthy and Mukesh Ambani. And various celebrities have also become the victims of deepfakes, that their deepfake videos have been circulated on social medias like Instagram, Facebooks, and various kind of incidents are increasing day by day. So the motivation behind this Fusion X was that to overcome the challenge of deepfake and build a model that can detect deepfakes efficiently, as well as it has a less memory overhead. So efficiency as well as accuracy we kept in mind. Next slide, please. So what is the innovation behind Fusion X? Why Fusion X is different? Next slide. So FusionX is a custom-built hybrid deep learning model. We are combining the CNN, that is convolutional neural networks, and the vision transformer into this. And the main thing is that it helps us to identify both pixel level and semantic level manipulations. So it is designed mainly for precision, adaptability, and real-world readiness. Next slide. So now let's dive deep into FusionX model architecture. So this is what I was talking about. This is a model architecture. As I said previously, that we have combined the CNN and the vision transformer blocks. So the S0 stage and the S1 stage consists of the convolutional blocks. S0 stage has the simple convolutional 3 by 3 blocks, and it has a stride of 2, so that we can capture all the local so that we can capture all the pixel level or the local level features of the images. And after that we are moving that data to the S1 bottleneck architecture, which can be repeated L1 times. So our models, another feature is that it can be generalized also. The model layer that the models layer, that is the S1 layer, we can repeat it to increase the capture of local features as many times as we want. Okay, so in S1 we have the convolutional one by one block, then depthwise convolution, and then again convolutional block. And to prevent the feature loss that is happening, like only we are capturing the local features. So to reduce the feature loss that is happening, and to also capture the other features, we have also included a skip connection from the first block to the output of the second block, that you can see the arrow combining that. And after the two blocks, initial two blocks, we come to the S2, that is the transformer block, which also can be repeated L2 times. So it has multi-head attention. Basically, it has three heads, and then the simple addition normalization layer, and the feed forward layer, and the again normalization layer, and it comes to the output. So our problem is like the basic binary classification problem: is it real or is it deepfake? So transformer layer, transformer encoder layers, and the multi-head attention layers, it helps to capture all the global features as well. So this, by this we can capture all kind of deepfake features that an image can include. Next slide, please. Okay, so now I would like to hand over to Adish Pawar. He'll be carrying Durgesh Sonar. He'll be carrying forward. No worries. Myself Durgesh Sonam. So I will be explaining mostly the training part of the Aqua system, and the backend and front end part, which I will give a short demo on it. So first part is PyTorch distributed training. So what we have used for training our model is we had made a cluster of 6 GPUs in our college, where we trained our model. So we implemented that using PyTorch. In PyTorch, we used a torch.distributed so we use torch distributed package. It was used for mainly communication between the GPUs. So each GPU had one processor. We can say it as a node, and we used NCCL for the communication backend. So it made use of Ethernet to communicate with each of the processor and share the data, whichever for the training purpose. The connection workflow is also given. We assign ranks, and GPUs exchange gradients and parameters within themselves. Next slide. For then there are two methods which we implemented. The first one was FSDP, that is fully sharded data parallel. What this does is, as you can see in the image, we uh, whatever model we had, we sharded its parameters into multiple processors. So each uh, processor used to use its sharded model structure for parameters and train on the same data. Let's say there's 10 GB data. So each model used to train on the 10 GB data, but using the some partial parameters. So the advantage and limitations are also given, that it was had low memory usage and scales up to billions of parameters. The model, if it is large, then we can use this method. Can you take the next slide? Uh, Just a minute. Yeah. So the next part we used was DDP, distributed data parallel, which we have currently used in our system now, because our model is not that big. Compared to whatever Google and large scale LLMs are doing. So we use DDP in our current system. And what it simply does is, whatever data set we have, let's say we have a 10 GB data set. So the data set is sharded into multiple processors. So each processor will get around 2 GB, we can say 2 GB, 2 GB, 2 GB. Like this, every processor gets a data set, partial data set. And the advantages of it are simple, it is simple, and it has high throughput. The limitations are high memory usage and not efficient for extremely large models.
Go to the next slide. Okay, so this is a short intro about our backend. We have the backend routes and features. So whatever what we have done is we in our backend system we have used four routes. First one is image detection, which is the main route where the user can send a single image for the image detection, and also our plugin uses this route to send those images and those are detected. Uh, then we have used a get model, which will fetch the model which user is using. Like we have two models in our current system. One we have named as 1.0 and the second one is 1.5. The 1.5 one is the better one. So this route will determine which the user has subscribed to. Then we have a subscribe route so that user can subscribe to a better model, and the authentication for login and sign-in purpose. So there are also we have added a secure authentication using JWT. There are tokens for login and user data management, and we have used Fast API. So I will just give a short demo. I will share my screen.
Durgesh is sharing the screen. He'll show you the demo.
Is my screen visible?
Yes,
Yes.
yes.
Uh, so this is our login page where I will just log in. Currently, our server is on local system. We haven't deployed it anywhere. So we can see the model using 1.5. So I had subscribed to this model. That is why I'm using 1.5. We can always switch to if any new user comes, you can always switch and subscribe to a new models. So this image shows the confidence score as 69%, and it is real. I will show the plugin feature. So I have loaded the plugin in our in this browser. I'll just switch this to on, and if I search anything, let's say uh, any image, so it will take some time and show us that is the image real or fake. As you can see, this is my profile and it is showing green right now. So this image is real. Uh, this image is showing the green border, so it is real. This is fake and this is fake. Now also you can see the images are processing it.
2 more minutes remaining.
So I will hand over to Alish now. Thank you.
Okay, hello everyone. My name is Alish Pawar. Now, from we have came to know about like core engine of our whole system. Then from core engine to real life word deployment, our defect detection system has started with a core engine called a trained deep learning model capable of a distinguishing between the authenticate and manipulated images. But building a model isn't enough. So deployment in real world requires a scaling, scalability, and reliability. That's why we design a high-level system design. As you can see in the diagram, this is the HLD of our system, having a multiple component like GPU cluster, load balancer, API gateway, caching and database. Mainly, GPU cluster is required for evaluation. When the inference is created, there are multiple crowd here there, and for that evaluation, we need a GPU cluster on server side when inference is created, and a load balancer to manage the whole clock. Then we will move forward with the real life scenario. There are mainly two scenarios I have mentioned here. The first one is a competitive exam registration portal for the ID verification, and second is the social media application for content moderation and user preference. Now, why the defect model will play a role here? Like imagine a student registering for a high stake exam like a NEET. When they upload their image ID, it automatically send to a detection API, which if the model verifies the it is verified or authenticated images, then register proceed smoothly. Registration process will be proceed smoothly, and if the image is flagged as a defect, the system alerts the student with a pop-up like your image is fake, so re-upload that image. This prevents the misuse of fake IDs and ensures a fairness in exam registration. After that, moving forward to the social media application, nowadays the content moderation and user preference is more important than the privacy. Uh,
when having a multiple fake images in our feed is not unlike to everyone. So now consider a social media app. A user often see a manipulated and misleading content. With our system integration, if user enables the option of hide deepfake images, the Fusionix scans the post in a real time, authenticate the image are displayed normally with the verified by Fusionix AI tag. If deepfake and manipulated images are blurred with warning, if we found a deepfake images, it is blurred with the warning that this image is flagged as a possible deepfake, so you can't view that. If anyone if user have we have provided user with the full control that they can choose the if any way option, like I want to see that image, so he or she can. And then this allows platforms to maintain a trust with respecting user preference. So for as you can see, there are two architecture images, so this can be our real life use case. Then moving forward, from core AI, from core AI research to scalable deployment, our Fusionix system demonstrate how the defect detection can directly integrate into real life application or real life scenario, from exam registration portal to the social media feeds, solving real life foreign problems at scale. So that's all about from our side. This is our defect detection system for a scalable solution for the real life problem. So thank you so much.
Thank you, team. Thank you. Thank you for the presentation. Over to the judges for Q&A.
Yeah, thanks. Varghese, please go ahead.
Yeah, for training purposes, you said your size of the model that you used was 10 GB.
Like I just gave an example for our data set, but the actual data set was
Actual data set was varying because since this was an R&D project, we were experimenting with various kinds of data sets, and then we finalized a data set of AI generated images which was of a size about 4 or 4.5 GBs, and the images were of size of 256 by 256 resolution. So then we need not waste our computational power for resizing those images. We directly fetch those images into the required resolution there.
And what was the number of deep fakes versus real pictures in that?
The ratio.
Yes.
It was like 75,000 images for real and 70,000 for deepfake. And then we divided that into the train, test, and validation sets for training purposes.
So you use the same model, meaning set of data for the validation as well.
Sorry, sir, I didn't get your question.
Did you use the same set for validation, or did you choose a completely different set for validation?
No, sir, we did choose of the same data set. We created a different subset
Okay,
of
got
the
it.
validation. So we did that. Yes.
And how different were the images? Were they all people of the same category? Were they different, and so on?
Well, they were a mix. So, what we tried to include first, we had only a data set of deepfake celeb deepfakes data set. So, it only included the faces, and the faces were morphed. But then, the problem of generalization was there. So, we've shifted to the new data set, which I mentioned before, the 4 GB one, and it included almost all kinds of images that were AI generated, edited with AI in the deepfakes part, and the real part included all the real life images of cats, of animals, of dogs, of humans, and of even in landscape. So we wanted to generalize our model more so that it can detect any AI generated image too. So for that we did this.
Okay, Satish.
Yeah, thanks for your presentation. My name is Satish. First of all, how do you define deepfake?
So deepfakes are the images which have been edited semantically. Their pixel values have been edited. So the values are the images which have been morphed with some other layer, that can be a deepfake. A completely AI generated image is also a deepfake. And some images where only the face, the complete face and the facial features with the pixel values of the image have been changed or have been manipulated with are can be called as deepfakes.
What do you mean by pixel value?
Pixel values means the RGB values, the red, green, and blue values. Because
And
since we have to look for the pattern in the pixel, because AI generated images have a pattern in those RGB values, and the real life images have a different pattern. So that can be the binary classification problem here. And by converting an image to the tensor, a 2D or 3D tensor, we can compare that values with the real life images, and by that we can distinguish between a real and a deepfake image.
so the strategy generally is that you are training the model first with the real images, and then you're trying a deepfake, and it will report a deepfake. Is that the general principle?
Yes, sir. We are providing the sets of the real as well as the real as well as those deepfakes to the model for training purposes, and then after that the model, when given an input for testing, it will give a output that is it a deepfake or a real one.
So now, generally, there are two approaches. One is that you are looking for how true the face is. The other is whether there are any artifacts arising out of synthetic creation of an image. Now, when AI creates an image, it leaves artifacts, which are some patterns. Now,
Yes.
if you're looking for that approach, then you don't need any other thing. You can straight away look at the image alone in isolation and see whether it carries the artifacts that typical AI generation has.
Yes.
And if it has it, then you can say this is a deepfake. The other is to compare with a real image. But the problem with the real image is that you need a lot of photographs of a real person. If it's a new person, if it's a new film actor or actress, you may not have all that. So how do you compare these approaches?
So the approach which you explained the last, that is the real images, that approach we had taken for, because since deepfakes, the images are edited to the very basic level. The first approach where the artifact approach which you mentioned, in that the naked human eye can distinguish between the AI generated image and the real life image, but the deepfakes, many times we cannot distinguish between a deepfake image and a real life image. So due to that, we wanted to evaluate the image at a very basic level, and then make the model understand that is this image deep fake and this image is the real one. So this is why we took the second approach.
But then you don't need to look at using the real eye, human eye. The whole reason why the computer is used is to look at things that the human eye cannot see. So why do you then fall back onto the human eye methodology?
So the human eye, again, like the human eye methodology, many times, like a deepfake video of any celebrity, a person cannot distinguish that. So the computer itself, it will classify those things into the deepfake and the real one. And
Okay,
since
I think we're running out of time. So one last question.
okay,
Suppose you take an image of President Trump and you
yes,
flip it left to right.
yes.
And what does your system say if you give
it
this
will
image?
it will give the real value, like whatever the value is, the classification category will not be affected, because since we are dealing with the pixel values, unless and until a
No, but the
pixel.
pixel values change, no? When you flip it.
But the pattern, sir, the pattern
So
matters
what are
here.
you then comparing? What is this, the pixel values that you're talking about? What is the grid of
the grid
pixels?
the grid of pixels contains the red, green, and blue values. So
That I know.
every AI
But
generated
size, what
image,
size?
256 by 256 initial.
But that's a very small stamp size kind of portion, isn't it? 256 by 256. These days, images are at least 2048 or no, 1024 at least.
Yes, sir. But due to the hardware constraints, we were not able to include the larger image sizes, because that was the main purpose behind using the 9 node cluster. Because our college didn't have any powerful GPU to single-handedly train that, And even the online services like Google Colab and Kaggle, Hugging Face, they did give us the free time of only 30 hours per week. So we couldn't rely on that. So we wanted to take the things into our own hands, so that so then we took this approach of distributed training, and we created this cluster. So
Okay,
that's why.
that's okay. So thanks, Varghese. Any follow up?
Yeah, just one follow-up. You talked about this at scale. So how at scale, are you looking at a cloud-based deployment? Can you go back to that architecture?
Yes, yes, yes,
Um,
yes.
okay. And how do you plan to deploy it at scale?
So currently we try to deploy it on a free services like Vercel, and we also tried for AWS, but currently it needs larger RAM servers, because for our plugin we have to fetch multiple images and send multiple images to the server.
Mainly, sir, for evaluation, on other hand, we have model architecture, and on other hand, we have the images input, or we can say the tensor. For comparing this, we need a kind of a evaluation power to classify between the real and deepfake. For that, to handle the whole huge cloud and the huge image data, so we need on server side or deployment side, we need a kind of GPU cluster. So
No, I
after
agree. I agree. Right. I am not asking. I didn't ask you whether you deployed it or not. I'm just saying from an architecture perspective, I don't see a whole lot of cloud native elements here. So that's why I was just checking. Did you look at what cloud native architectures look like for large scale scalable deployments? Because this doesn't look at. So that's why I was checking if you used, for example, AWS as a well architected framework for deployments and things like that. Did you
we,
use any
sir,
of those versus?
our model is trained on PyTorch distributed cluster. Then we came across a concept like a PyTorch serving or TensorFlow serving. We can use that kind of services to serve our model. Mainly, there are many cloud platforms like AWS, as you have mentioned. We can use an instance for that matter.
Okay, thank you.
Thank you, sir.
Thanks, Arvind. Back to you.
Thank
Yeah.
you.
Thank you, judges. Thank you, team. Thank you for your presentations, and thank you, judges, for your questions. Team, you can leave the meeting.
Okay, okay.
Thank you.
Thank you.
Thank you. Suspin, can you please confirm the team has left?
Somebody new has entered. Is it the next project?
No, that's Nathan. That's our volunteer.
Yeah, I think the previous team has left, all of them.
Okay, then we will be going ahead and calling the next team, sir. So, or do you need anything? Yeah, sure. So then we will be going ahead with the next team. The next team will be IIA 251 auto grade. The team member joining will be Alan Manu.
So one sec. Where is the last team from? Which institution? I
It's
forgot.
from Pune. Let me just give me a minute. The college is PES Modern College of Engineering, Pune, and the next team will be from St. Joseph College of Engineering and Technology, Palay. The team,
Okay,
the
go
project
ahead.
title is auto grade. Sure. Okay. Admitting the team. Hi, good morning, team. Alando, can you hear me?
Yes, sir, I can hear you.
Sure.
Am I audible?
Thank you, Alando. Yeah, you're audible. Thank you for joining today. So we have Satish Babu and Varghese Sirian here as the jury member.
Okay.
Okay, you can like to jury. This is Alanga Manu from St. Joseph College of Engineering, Pale. They will be presenting their project right now. So you can go ahead and start Alento menu. And the thing is that we will give you a warning at 10 minutes because we are planning for 12 minutes of presentation, and then the floor is open for Q&A. That's how we are planning, as already
O-
communicated. So you can
Okay.
start. Thank you. And
Okay.
will you be on video mute or will you be turning on the video?
Okay. I can turn on my video.
Sure, thank you.
Okay.
Sure, please go ahead.
Okay.
Thank you.
Oh,
All the best.
okay. Let me share my screen. Okay. Is my screen visible?
Yes, yes.
Oh, okay. Myself, Alendo Manu. I'm from St. Joseph's College of Engineering and Technology. I'm here to present my project, AutoGrade, an intelligent exam sheet scoring system. This is guided by Dr. GP Jose, our HOD. These are the contents of the presentation. And coming to the project overview, this is an AI-powered platform. It is designed to automate the grading process of the descriptive handwritten answer sheet using the cutting edge technologies and large language models. This project aims to eliminate the need of manual checking, and it delivers fast and accurate and consistent evaluation, transforming our traditional educational assessment process. These are the problems solved with the help of this application. This reduces the grading time and saving the valuable time of the teacher, and it cut the evaluation cost with the help of the AI-powered automation, and it gives the student the clear cut evaluation results and feedbacks based on where the mark is reduced. And it gives the students usually need to pay for the answer sheets, but here we are providing it via cloud. Instantly, we are delivering the results, so it eliminates delays and stress. And it also provides a real-time tracking for the grading and process for the teachers. The core architecture of this project is mainly the front end is built with Next.js for the responsive UI and everything, and the backend is built with Node.js, and this is for the PDF processing and handling a load and everything. And I'm using the large language model here as MetaLlama 3.2 vision model for OCR, and I built an OCR on the top of this model, and also we have used the 3.3 instruct model for semantic grading. Database is used with the help of Postgres, and I have used ORM, main name Drizzle, which is hosted on Neon serverless, and I am using Redis for the caching, which is provided by Upstash. And the cloud provider I'm using is Cloudinary, and have hosted this application in Vercel, and also the backend servers are hosted in Vercel. Run, Coep, and Railway. And here the vector store is coming from the same Neon serverless system. It's a PG vector store, and I'm using Hugging Face embeddings too. The entire thing is automated with the help of GitHub Actions and Docker. Whenever I commit the change, commit anything to the main branch, it will automatically push to the Docker hub, and the image will be rendered on the particular several servers. And these are the implementation details. The OCR pipeline includes a PDF Poplar module, which is capable of extracting the handwritten text to digital format. It is done with the help of MetaLlama 3.2. And here I am using the reasoning-based evaluation. Here the descriptive answers are evaluated based on the reasoning model of MetaLlama 3.3 model, and also it is implemented with help of the RAG. The data storage and using the Cloudinary for storing answer sheets and answer keys, and also for reports and scores, we are using PostgreSQL. And for cloud native solutions, basically everything is hosted on cloud services like serverless Postgres and Upstash Redis caching for recently used answer keys. And this entire application is built on load balanced with the help of multiple servers, and there's a round robin logic is running in the background to balance the load whenever multiple users comes to the system. Here, real-time insights are provided to the teachers with the help of dashboards, and for students, we are using such several graphs and for showing the student performance. And here, the performance metrics of this particular project, the accuracy of the OCR is around 97 to 99%, depends on the handwritten clarity. And the evaluation time is only takes around 3 to 4 minutes for a 30-page answer booklet. And here, the time for the teacher, it is saved around 95% than the manual grading. The variance of the manual grading basis this system is only around 2 to 3%. It is this result is actually achieved from 30 to 40 paper evaluations, which is done in our college itself. The cost efficiency is around 70% comparing to the manual's current ongoing systems. The future scope is this particular project is like we can enable multilingual grading. Currently, this particular project supports English, Hindi, and a couple of languages. But here we can also include multilingual language. Okay, also here the complex diagrams and map derivation can be evaluated with help of some vision models, and also we can implement the plagiarism checks for deep for analyzing the copied content and everything. And also there are for bulk upload and large scale processing we can integrate up in whenever the product is on sale. Then also we have this similar technology can be adaptable to school boards, coaching centers, examinations, competitive examinations as JEE Advanced and everything. That's all. Thank you. I will share my screen for showing my software product. Am I audible, sir?
Yes, you are. Yes,
Ah,
you are.
yeah, yeah, yes. This is actually the software which we built for this evaluation process. This is the home page for the teacher, where we are mentioning how these things was, how to use. We are also providing sample answer sheets and sample answer keys. Also, we specified a answer key format. This is the most common format which is followed by every universities. The KTU is following this similar structure, so we followed the same structure. Here, this is a teacher where the evaluation process is going on. Basically providing the teacher's ID and details. I uploaded the answer sheet upfront because for saving the time. Okay, here I uploaded the student answer sheets for the demo, and the next I will convert this answer sheet to the digital format. Here, this is done with the help of the OCR. This is not like our common OCR. Whenever we come with the normal OCR, we will definitely fail when we're coming with the hundred things. The core idea to come up with a LLM to build an OCR is like how our teachers will able to evaluate our messy answer sheets. It is only because of his or her experience in evaluating the answer sheets. Couple of universities, he or she have 15 or 16 years of experience in evaluating this messy answer sheet. If as a student, if I ask my friend to evaluate read my answer sheet, he may, if it is messy, he may not be able, but my teacher can. This is only based on the subject knowledge. Plus, the second factor is the experience. So basically, when we go with those here, the experience is there, but the subject knowledge, such kind of things won't be there. So basically, when we come up with the LLM, we have an idea, and whenever we add a top layer for this OCR, it will perform best. That's why we got the results. You can verify the results based on this meter per second and everything, how messy it is. But actually, we are able to do that in a perfect way. The next part is like we are uploading the answer key. Here, the answer key is uploaded. This basically the format is like the answer question will be there. Then if there is a the explanation 2 mark, example 2 mark, such kind of answer key is provided. How our university provides. Here the random implementation comes in. Whenever the question comes to the model, it will definitely retrieve the question. Plus, whenever we can upload pre-upload the PDF study materials, all the study materials related to the course. So definitely it will fetch the thing, and it will retrieve the documents and chunks of the data. Plus, it will re-rank it and for the token limits and everything. So we will re-rank it and provide the top 10 element, 10K elements. They will be provided. So based on that, it gained a domain specific knowledge for the evaluation. So the evaluation will be crystal clear. That is a key thing. This is a Redis actually with the provider. Here, the answer key, which is recently used, is cache. So here, when I select it, it will become from Redis. So this is whenever I hit the next button, can see the evaluation results. Here, the first three questions are evaluated with 100% of confidence, where the fourth question is not 100%. That's why it's open the textbooks. Here, the confidence level reduced because of the diagram. Here, the diagram it's complex, so it is unable to detect. It's because if we want to achieve 100% of accuracy and consistency, we can't go with diagram. So each person will draw in a different manner. So basically, we can't go with it. So I just manually overrided this thing, and it will dynamically fetch the answer diagram marks from the answer key, and it display here. This two what I am showing in the text box is the theory mark. That the just the 2 marks for the diagram. So teacher can only award 2 marks for the diagram. Apart from these things are not editable fields. So whenever we can after the evaluation we will go for the thing. Here there are a lot of logics like revaluation, such kind of thing is implemented. So basically the previous student ID will be matched against the database, and it was called already as just either it might be a revaluation or the teacher may misenter the student ID. So we can go for the both thing. So okay, we can go for the thing. I just entered a student ID and the student score got saved successfully. Here, the next whenever the score saves, the teacher can go to the analytics section and teacher can view that what are the courses teacher evaluated and what are the things paper subject. Here, in detailed course can be evaluated. Here, the teacher can set a pass percentage and download the Excel sheet for these particular students, and it can be exported easily. So teachers don't want to take a extra effort for doing this thing. So the next platform is for the students. Here I have a student platform where the student have a separate login. Here after the login, the student can view their dashboard. Here I'm just going for Google login. Here you can see after the login, I can see the dashboard. This is student dashboard. Here you can see the currently evaluated course. Here when I go to the course, here we are displaying our answer sheet. This is stored in our cloud storage. So basically we need to pay an extra amount to the universities to get this answer sheets. Currently, we reduce the cost. So currently 750 or 850 rupees is not supposed to be paid by the student. It is displayed here. So they can do that part. Also, apart from that, we are also giving the question-based analysis, and it will clearly mention that where the mark is lost, why the mark is lost, what is the real answer. The thing is like whenever it has the subject knowledge of the particular LLM can reason accurately and it gain the domain specific knowledge. So basically we can give all those informations perfectly. That is a key idea of coming with this reasoning why the mark is the feedback for the student. This will definitely help the students to enhance their learning experience and everything. Also we can provide some chatbots because the model gained all the long knowledge about the course. So we can definitely give a chatbot and student can ask any questions related to this. This is the software we built for this thing. I finished my presentation. Uh,
And then to a quick question.
yes, sir.
How much of documents did you upload from a RAG perspective, right? You said study materials can be added,
Yeah.
answer keys can be added, potentially past answer, evaluated sheets could be added. How much of that did you actually add?
Actually, I come up with I just tested with our normal CBSE biology science. So I just download the documents from the CBSE website and just uploaded that documents for the RAG structure. That is a key idea behind this RAG structure. So basically, whenever that question comes in, I will extract the question by pattern matching. There's a logic there. So I just extract the question. When basically, then the RAG will be, semantic matching. Basically, they will go for semantic and retrieve the related chunks from the thing, and I will re-rank it with a model which is running on the CPU, a small Hugging Face embedding model which is running on CPU level. So it will retrieve that thing, and I with the reasoning model. So it will append the content specific, domain specific knowledge to the LLM, so it can reason correctly, and it can basically it got the answer key. So they got the answer key, basically the explanation, and now the model knows what is the right explanation, what is the right example based on this. Right.
Okay, how do you make sure that if the question is slightly varied, right, you will
Yes.
get the same result? Because that is where the hallucination typically would occur, right? Because if it doesn't understand the question, and if it can't get the feature, very specific feature, you would probably have the LLM hallucinating. So in this case, how much of feature mapping did you do? Because if it is 100% feature mapping, then obviously we are going to have challenges when the questions changed or the questions are reworded, right?
Basically, we basically give this answer sheet. I mean, the digital answer sheet of the student, particular question. Plus, we will append the answer key plus
Okay.
the RAG document. So basically, we set the temperature as 0. So basically, it won't think more. I mean, it won't. Basically, if we
Okay.
set the temperature.
So what you're saying is the exact question with the answers or the answer key is what you load from a matching perspective.
No, I mean we have two modes, sir. In that LLM itself, we have two mode. Actually, there is a liberal mode and normal mode. In liberal mode, it will evaluate liberally. Whenever it comes to the normal mode, it will normal. But we are actually setting those things. We can manually change those things based on what we want. That's the case. So if it is coming for the liberal mode, it won't be checking that as it is. If the answer is as it is not, it will think like a teacher. Okay, from the teacher perspective, he is expecting something like that. Does the student actually gain some information, or the course outcome or the program outcome is gained or not? That is the core logic of the examination. So in the point of the examination, it will think and just reason.
Okay. And this is a very well written, handwritten document, meaning this is not how messy. If you say this is messy, I would disagree with you.
Yeah, of
So,
course, that's
what
true.
levels
So
of messiness did you test out? Because accuracy of 97 to 99% is almost impossible for any kind of
yes.
written document. This is a very well written document, right?
Okay,
So,
that's
so
really
how much of variance did you do?
actually, I mean, I presented this in a conference, and they actually tested in multiple scenarios. I will show, if you are ready, I will show a document. I mean, they uploaded a document. I mean, which is not easy to read by a ML model. I will try to upload the document and show you. I mean, is it the level of messiness? I mean, it won't be too. I mean, it's actually it's not capable to read perfectly, but it is. Mm. This is a document actually they're tested with. So, are you visible, sir?
It is
Hello?
visible, yes. Sorry.
Yeah.
Yeah.
I mean, is it okay? I mean, each word is not too easy to read actually. Some of the thing is like, but is not able to. This is right actually. So this is the level of messiness I think what you expect. Is it right, sir?
No, but that's okay. I think, Satish.
Okay.
Yeah.
I mean,
Thanks
whenever
for
the
your.
student is okay, ready for right, I mean, the teacher should understand. Okay,
And
it will
hold on.
understand.
I think Satish has a question.
Yeah, thanks for your
Okay.
presentation. So, are you aware of any universities or colleges who are using not your product, but any similar product which is using 100% AI to score
Mm,
sheets?
Uh, no, I never seen. I actually went for an expo. I mean, they invited us to present our software for the expo, but many LMS providers actually reached us because they are ready to integrate. But they're told like currently we don't have a such thing in our market. I mean, like this evaluation is. I mean, this kind of the end-to-end software is not available in the market. Like processing the thing with the help of LLM, it's not available. I referred several IEEE conference papers, I mean papers, research papers. It did, gives like some of the, I mean, question paper, I mean, pattern, question paper like keyword mapping, keyword matching is there. Whenever it comes to, it is not reasoning it properly because they are not using LLMs. So
Okay, so are you aware of the reason why most universities prefer not to use such a product?
hello, sir. Can you come up once more? I didn't
I
hear
said,
it.
can you think of some reasons why? Because the LLMs and AI has been around for more than a year now, and
Yeah, yeah.
theoretically it is not very difficult. Why do you think universities have not adopted this in large scale so far?
The thing is like there are multiple scenarios. I mean, when in our current system, I mean, if a student can write in a specific way, then student can continue the answer sheet in this line. I mean, if it start from here, student can write from this here. If we coming to a math question, sometimes he can mess up the lines and everything, so it will be hard.
Okay, let us
The case.
differentiate. The first
Yeah,
task is the OCR, that is
yeah,
conversion of a answer paper into something that is computer readable, which is
yeah.
maybe in ASCII or in some other format.
Ah,
That
yeah,
is one task. There
yeah,
are significant challenges there. The second task is given an input in computer format, which means docx or PDF
yeah.
or whatever,
Ah, yeah,
judging that. And
yeah.
both these tasks have their own challenges. I'm not convinced that Varghese' question is very relevant. I'm not convinced that the first part, that is parsing a handwritten document in a technical subject, meaning these are all exams, which means, at least 12th plus kind of grades. And these are subjects which have a lot of jargon, meaning language specific to that subject, which is not general purpose.
Yeah,
So
yeah.
the conversion of that handwritten text with anything above about 50-60% accuracy, I'm not able to believe that that can happen. That's number one. But
Okay.
that's not where my problem is. That is a
Yes.
significant challenge, that
Okay.
converting this handwritten stuff into sensible text.
Ah, yeah, of course.
Second part is to do with the actual scoring of the text.
Yes.
Now, what do you think are the ethical and legal implications of such a tool? So suppose you apply this. There are many ways to fool the AI. For example, just like you have deepfakes, there are ways of fooling AI. There are ways of determining whether it is AI or not. There are so many complications there. But what do you
Okay.
think are the ethical and legal implications of this? Suppose the student goes to court and says
Okay.
this AI has not understood anything of what I have written.
Oh,
What will
okay. But
happen?
we are actually providing the reason why your mark is lost. What is the reason behind losing the mark? So
That is not
definitely
so
student
easy.
can refer
Suppose
those things.
a descriptive question is answered by the student in a certain way. Now, when you
Okay.
say answer keys, these are not
Okay.
objective type questions. Objective type questions, any computer, they've been doing it for last 20 years.
Yeah, yeah.
But
It's done.
subjective, open-ended type
Yeah,
answers,
yeah.
how do you have a key for that? I don't know. So when you say you
Uh,
hand over the keys, how do you have a key for an essay
I
about
mean,
any?
this is how our university actually follows. They are actually following like
Yeah, but you have
if
taken one
in
subject.
particular
You
question
have taken
they
one
have.
subject. I'm talking in general I'm talking about, say, linguistics, which is a subject in your university.
Okay.
And the linguistic question is about comparison of Indo-Dravidian languages. Now,
Oh,
there are
okay.
so many ways of writing an essay like that. What
Oh,
would
okay.
the LLM do with that?
Uh,
What kind of key can you hand over to a LLM?
Oh, okay, okay. I mean, some papers don't have the actual what we expect. That's the key thing. But
And
when we
so
talk
that's a
with
legal
our
question I was talking
HOD
about,
and our
that they can go to
principal,
the
they
court.
actually told like majority of our KTU answer papers, I mean answer sheets, which question papers, which is released, have a key in with the university. So they
No,
basically
hang on,
they are
hang
this
on.
key
It is not
provided
over.
hand over.
I was talking about the legal aspect of it. Somebody can go to court, and then it's very, very hard to prove that the AA is right.
That's
Then they'll start questioning the key. If you have such a thing called a key for a open-ended question, but what about the ethical aspect? Have you heard of bias in
but
LLMs?
yeah.
What is bias?
I mean, like, it can vary based on the how much I mean, how you access the LLM. I mean, it can vary. I mean, different times it won't be consistent. Inconsistency is there.
Bias has been well documented in AI, and there are
Yes.
significant issues, shall I say. So I'll stop here.
Okay.
Varghese, any closing questions?
Hello.
One sec.
Um,
Yeah, go ahead,
Meaning,
Varghese.
I think you asked us my second question, which was the scoring part and how much of reasoning is around the scoring. But I think I leave it at that. One more thing, did you use any papers? You said you checked multiple papers, but there are many papers around identification of handwritten and then conversion of that into reasoning.
Oh,
Uh,
okay.
did you use any papers around it? Did you check with, for example, where did you get your set of answer papers? That was
Answer papers or answer keys?
answer sheets, handwritten answer sheets, and obviously the keys as well.
I mean, we just created. I mean, we have our own internal examinations. I mean, answer sheets. We just took it from our college itself, and we just trusted. I mean, the teachers are really interested to check it whether it will work or not. They are really interested to check it. So basically, I mean,
Okay.
it didn't. I mean, whenever we tested it, actually,
How
it
many?
didn't
How
fail
many?
too much.
How many did you get, and how varied were the subjects?
This actually, I mean, was not too much variance. Like there was some questions from, I mean, computer network was there. Some of those DBMS was there. I mean, diagram question, I mean, diagram answer sheets were there. Also, some there were. I didn't take some answer people like engineering mechanics or something. It will definitely fail because it's full of diagrams. So that kind of things it will definitely pop up. I mean, open a textbook. So it doesn't make sense. So basically,
Okay.
rest of the around 30 is taken. I mean, teacher put the 40 mark answer sheet. Teacher put around 35. Our thing gives around 32. So teacher told like, okay, this is because if they ask that it's a particular question, it is actually reduced. So if I ask the teacher that why it is reduced, because teacher said like, okay, I think like the student understand what I mean he studied, or I mean what he understand the
That
topics
is
that
that
hey
is the question that Satish asked,
ah
right?
yeah
If
yeah that
right, if the
ah
if let's say in this case you go to court, I give you the solution, you go to court and say that I got
okay.
32. Now you see the difference between 35 and 32. 32 is failure, and 35 might be a pass,
Okay, yes, yes.
right? Now
That's
that
it.
you
That's
can
it.
now that is why Satish asked that question, right?
Yes, yes. That's the thing.
Okay.
Yes, there's a slight variation will be there because the inconsistency is there. Of course, there will be. Of course, but it's not too much inconsistency. If it's 2% or 1% is
All
actually the
right.
teachers are
Thanks.
got accepted. Okay, if it's in a primary level because the reasoning is anyway they are giving the feedback. So that student can actually ask for if a revaluation or such kind of things needed, we can give a button or something for the revaluation for the particular question or something. We can do that part.
All right.
Okay.
Thanks. Thank you.
I have a couple of add-ons, the suggestions for you. First is that the main problem with this approach is that there are no safety nets, which means there is no human being that cross-checks some of this, at least the outliers. Suppose somebody gets 100% or somebody gets 2% marks. There's no human being to cross-check what the heck is going on. So if it is human aided, so it is AI plus human, then there is some scope of at least for some non-technical subjects that this could be used. And the second is that there are places where such a tool is useful. So those are not complicated legally or ethically and all that. Suppose somebody wants to, capture some written notes or something like that, and store it somewhere. For those kind of things, there may be a utility in such a tool. But for exams, I would say it is very difficult to kind of use it as it is. So thank you very much, and back to
Okay.
you, Arvind.
Oh, okay.
Thank you, judges. Thank you, Alento.
Okay.
Thank you for your presentation today. You can
Okay.
please leave the meeting room. Thank you.
Oh, okay. Okay. Thank you.
So Alento is out. Now, can we go ahead with the next team, sir?
Yep.
So the next team will be the team ID is IAS 0299 EchoLink Intelligent Emergency Response and Crisis Management System. It's a project from Government Engineering College, Palakkad. So I'll be adding the team right now. I think we have Vishwanatha Karta and Ashik Rahman here. Can you hear us, team?
Yes, yes.
Okay, sure.
Uh,
Thank you
am
for joining today. We have the judges here, Mr. Sadish Babu, co-founder and past president of INAP, and Mr. Varghese Cherian, head of technology services at USG. Now, you can start your presentation. So you will be having 12 minutes for presentation as we have conveyed earlier. At 10 minutes, you will be given a warning. And once 12 minutes is up, it will be all to the judges. The Q&A will start. So that's the idea. We can start, and you can, if you have a presentation, you can start sharing it and start the presentation. Over to you. Thank you, Vishwanath.
Yes, thank you. So, Ashik, can you share the presentation?
One second. It's visible.
Excuse me, team. Sorry for interrupting. Can Ashik please mute? There is an echo coming in. The ones who is talking can turn on their microphone.
Okay.
So, hello everyone. So, we are Team Studio One and we are presenting our project that is EchoLink. So, okay. So, we all know what the disaster management, we all know about disaster management response, right? So, even with the advent of AI, we still have not we have not implemented a lot of the capabilities of AI into disaster response management. So we all are familiar with like incidents like Kerala floods or even landslides, Wayanad landslides, and all these situations. What an idea that came up with us is that we can actually implement the fast responsiveness of AI in order to actually augment the call centers in order to get them to a faster safety net. Okay, that is our main idea. So in the realm of emergency response, the efficiency and accuracy are really paramount. And for in traditional call center cases, for example, matters from I don't remember the exact place, but the matrices from uh, US call centers is that almost 63% of the call centers are actually understaffed. So in case of an emergency where lives matter, the 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 fast responsiveness is of ultimate importance. So if with all these in mind, we are presenting our project, the EchoLink AI, in order to actually help the call centers in it's not actually replacing the call centers or the people in the call centers. It is actually a method to actually help them to get to a faster response. Okay, so we all know that it is one of the fundamental rules of UI, user experience, is that it is easier for us to read than to hear, and it is easier for us to talk than to type. Okay, that is the fundamental tagline that we built this entire thing in. So, if you have an option between having to read an entire passage of a call response, or to hear the entire thing, the reading part will be obviously faster, especially if it is combined with the power of generative AI. So, Ashik, can you go to the next slide? So to improve the emergency call centers by enabling criticality analysis from voice data, efficient voice to text conversion, seamless call integration, and single click dispatch, effective spam detection to enhance the response speed and accuracy. That is the problem statement that we have chosen. So if there exists if there exists a tool that is actually able to uh, respond to users in a real time and decide which department or which force is to be sent to a certain place, all these extracted from the call itself, and have the call center operator actually cross verify this in a glance, and then send forces to that certain place in a very quick manner. That is I think that is a really important thing. Next, can you? Our objective of the project was to get the criticality analyst from the voice to convert the voice to text to have the call integration and single click dispatch and spam detection. So out of this, we were planning on a really great, awesome project, but in the end, as all good things come, there were many setbacks. For example, one of the very important thing that we couldn't actually do was that to integrate local languages. For example, like the of course the calls are actually coming in local languages. For example, if there is a problem in Kerala, the calls will obviously come in Malayalam. So for that, we actually tried testing models such as Wave to Wake. Wave to Wake fine-tuned with Malayalam language. There were models available in Hugging Face, but these models, even though they gave out a certain level of accuracy, but they were not up to that standard to be able to implemented in a system that actually requires a really good a response. Okay. So that is one of the hitchbacks that we face. Another problem that we faced is we wanted to integrate the calls from the mobile call itself, but that was something that we're going to do because of some limitations between giving out random numbers to. Uh, so we tried many services like Exotel and Twilio had a policy, but that actually didn't allow us to create numbers. So Exotel didn't allow us to create numbers to actually take these calls without actually giving a company registration or something, GST number and all. And for the case of Twilio, the international calls were taking up too much cost. So that is why we actually created a simple dashboard that actually takes the call. Uh, so it's an emulated environment, simulator environment. Okay, can you go to the next slide? So the incoming calls are actually so the ideal scenario is that the incoming calls are actually routed and to the speech to text module and to call analysis module. These are connect back to the LLM, then they are stored in a database, and then the operator can actually decide which dispatch service to send to. So here we are implementing an endpoint where an open standard where the dispatch services can create third party plugins for themselves. For example, if we have things for ambulance, fire and police, but things such as if there is a case where we need a third party service, we can have them onboarded easily with our endpoint. So it's just sending an endpoint to them, API endpoint to them. Okay, go to the next slide. Ashik, the next slide. Okay, can you skip that? So that is the UML diagram of this. So here we have the use case diagram. So I'm just speeding things up. And okay, that is, we had a great design, but in the end, we couldn't actually implement a lot of those designs because we wanted to have that fast product that uh, we made something quick with Python and PyQt. Okay, go to next. Okay, so let's go to a demo. And so for the services that we use, we have tried multiple services. Like I've told, for the call part, we tried things like Exotel and Twilio, and then we tried to source an internet. One or two international numbers, but that all went to a dead end, so we couldn't actually implement that. And for the PyQt, for the UI part, we did it in PyQt, and we have a demo page in in Next also, the intent and software. But in the one in PyQt, we actually used services we tried services for example, the latest Gemini live streaming service that just came out some time before our project's presentation. And then that actually had the support for local languages, but we couldn't actually implement that part. But what we implemented is that to use Hume AI, and also we tried 11 labs, but because of that time latency thing, we actually went back to Hume AI. What Hume AI gives you is to provide a live communication platform. So if you can have a live conversation with an AI, and it will give you the transcript of the text as well as the criticality, what the tone of the emotion or what the tone of the text is. That is what we are getting. And so let me share my screen. So here is a dashboard that we have. Okay, I hope you can see this. Maybe if I start the conversation, what will happen is that we'll see a live transcript of what is happening here. We have a database of whatever is happening here, and the problem is that you'll see that the transcript actually takes a bit of latency, and also it is that hmm, okay, see, the entire thing is being said, but now it will talk back to me.
Hello, this is Echo from Emergency Services. I'm here to help. Please stay calm and tell me what's the emergency.
Were you able to hear the sound of the this thing talking back? Yeah, okay. So here's the problem. Without a mic, it actually loops back. So there is a problem with that. So if I use a mic, then we'll be able to like have a conversation with the AI, like like a real agent. And if I end this call, so this is a simulator environment. So if I end this call, the conversation summary will be actually will be updated, and you can see it here. User discusses issues with the AI. Then there are all the histories that are not actually marked as resolved. There are some issues. So this is another conversation that I just started, and there's a fire reported near this place. So this parses the information of what the place is, all those things from the conversation itself. What we can actually do in the future is that if we can actually connect with the emergency services. So if we dial an SOS number, we can see that it is actually taking all the location details from the user and actually sending it, so we can actually use that for better responses. And so here we are showing a map and this problem, the place here. So if we click dispatch, you can see which service to send to that place, and we can actually mark this thing as a resolved, and that'll give you a green tag. You can see the history of what all were happening. So we can see a timestamp, you can see a summary of the calls, we can see the live transcript of the calls of each call here, and the criticality of each of these calls. For example, this was a dummy conversation, so the criticality is low, e-spam is yes, so the user is unknown, the location is unknown, because there was nothing much in that call, right? The same for this case. User discusses the low priority, maybe not a spam, and no other details were being sent. But in this case, we have a report that has a medium priority, and the location is actually given, and so that is the gist of it. So we can see the call histories here, and also the analytics of how many calls were taken, and all those details here. That so another intended thing is that we have a okay, excuse me. Okay, can you see that? Yeah. Okay, so in this live demo, this is one of the UIs that we envision. Like we couldn't actually like integrate it with the like proper front end only part. So this is actually a demo that is actually hosted in Vercel. So here we can click the police, and the dispatch service has sent police to that area. So we can see the like live emotions, or what the tone of the speaker is. So yeah, that is about it. Did I miss something, Ashik?
No, that's all.
Okay, that's good.
So your presentations
Satish.
are over, right? Yeah, sure. Over to you, judges.
Yeah, so my name is Satish, and my first question is, in one sentence, what are you trying to do here?
we are trying to improve the speed of disaster responses in call centers with AI.
Disaster responses in call center. What does that really mean? Can you give me a use case?
Yes, I can. So suppose there are like okay, of course, I'm sorry I didn't say it in the presentation itself because of the confusion. Okay, so suppose there are 10 calls that are coming to a call center. So a call center that is
So these are
already,
telephone calls,
yes, telephone calls.
not WhatsApp calls or
No.
SMS or anything else.
No.
Only telephone, voice
Telephone,
calls.
yes, voice calls.
Mhm.
So there are 10 calls that are coming up, and already the center is thick packed, and people are actually talking like suppose all the operators are actually talking back. So what our project does is it actually takes these calls in parallel and actually lets an agent talk to that, and actually lets the operators see in the dashboard how critical each of these calls is in real time, and if it is needed, he can actually see the transcript, and if he can actually see what the problem is there any problem with the AI that is actually talking back, or how if it is really critical, he can actually step into that call and actually connect with the person.
So what is really new? Because there are a lot of chatbots which communicate, through conversations with telephone lines. Earlier it was, you press one and press two and all that. Now it is all talking also.
Hmm.
So
Uh,
what is new in this case?
what is new is the AI. So the project started like 1 year back. So then we couldn't actually is there were no cases of in my personal experience there I haven't seen any kind of AI that actually talks back to the call in the context of a disaster management. And I have researched, but I have not found anything that actually does this exact thing.
Okay, so the problem with disaster is that it is time critical.
Yes.
It's also theme critical, meaning somebody may be about to die.
Hmm.
I'm not sure if you heard of a very famous case study called LAS, London Ambulance Service. You can look it up afterwards on the internet. So what happened is that in the early stages of computerization, about 25 years ago, the London computer dispatch of ambulances decided to switch to a computerized system from a manual system. And there's a lot of story, what happened actually and all that. But finally, it ended up killing many people. Sometimes the ambulances getting late by 12 hours, all because of the fact that the system could not anticipate what is about to happen. Now, your system, you're saying that calls come in, and if the operators are busy, then the call goes to an AI robot, chatbot.
Yes.
And the chatbot tries to do some kind of sentiment analysis to figure out is this critical or not. And then if it's critical, it probably pops up a message in someone's console saying, here is something critical, attend to it immediately. So the first challenge, of course, is in understanding if you are really talking about a on-the-field system, not a theoretical system in the lab, is in understanding what the speaker is talking about. So here in IEEE, we have dealt with many emergencies, like the Kerala floods you mentioned. But much before that, the 2004 Indian Ocean tsunami, where Kerala IEEE Kerala section team went to different places, including Tamil Nadu and Kanyakumari district and all that. The problem is when the call comes in, it is almost incoherent. It is not even good speaking, meaning the person who's speaking is under tremendous pressure. So to understand that person, if you do not know the language, if you do not know the place names, if you do not know the contact, the actual background or context, it is very hard. That's one challenge. Maybe we can overcome that challenge by training the network or something. I'm not sure.
Yeah, that is a challenge that is faced by by the tech, that is bottleneck of the technology itself, because we know that, even the latest technology is bad at understanding slangs, understanding the dialects that are there, or things like that. That is a bottleneck that the technology that provide that stops us.
Right. Then the second is you convert it into some kind of textual information, and then you do a sentiment analysis on it. How far is that
Uh,
kind of free from bias and all that?
So the sentiment analysis actually is not done in the text itself, but the human. For example, in our case, we are using Hume. So Hume actually provides us like the sentiment in the sound itself. So how hurried the voice is, how concerned the voice is.
In
So
what
it is
parameters?
in.
In what kind of parameters? What does the software tell you? This is urgent. This is not urgent. What?
It's not urgent. It is like the mood of the voice itself. It is sad. It is urgent. It is concerned. It is happy. All these things.
How does it tell you? Meaning, what does the function return?
So it returns the like it returns a set of parameters, like for example happy, like sad, concerned, all the like there are a set of values that are there, and it gives a provides a confidence for each of this.
Right. Okay. So we're not even looking at what happens subsequently, meaning there is a pop-up that comes up. We are stopping right there. Because the first stage and the second stage we talked about, there are many challenges, and these are not easily kind of the main problem being the context, not because the technology cannot do it. The technology is already available for various domains, but not generally. If you found a general technology that handles everybody's questions, then it becomes very language specific and all that. So there are challenges. I'll stop here. Varghese, over to you.
Yes. Before you talked about the solution, you looked at Hume.ai, and I'm assuming you're talking about Hume.ai and recognizing the human emotions. From a deployment perspective, how do you make sure that this is scalable? Because one of the other challenges, meaning to all the ones that Satish already mentioned, is something that you kind of considered, right? The call volumes. At the end of the day, the call center has only a limited number of pipes that they have, right? So call volume becomes a challenge. And if you're saying that if the pipes are all engaged, essentially you will pass this off to the agent,
Yes.
right? The automatic agents. Even the agents need to scale,
Yes.
right? Because there are, this is not a clean scenario where there is one call after the other coming, right? So you need to really look at how we can scale it. So from that perspective, what did you consider?
So for now, like as you see in the POC, actually is a completely locally running thing, and we haven't actually thought about like the scalability point of view. But what can be done is like so there is possibility. So we have seen that there is possibility of you may actually be able to take parallel calls, and we have also seen that for services like Exotel and Twilio actually providing us if a call comes to a pipeline, you can actually redirect to various individual pipelines or various endpoints that can be like it can be parallelized into various endpoints. So that is that if problems comes to that, then we can actually see we do see solutions there. All these services that provide the possibility of parallel working.
Okay. And then you talked about the dispatch, right? Which is the action part of it.
Yes.
Is that something that you're looking at from a voice perspective, or is that something that you're looking at from a data perspective? Because once you understand the human emotions, you understand where the call is coming from and all of that, what kind of dispatch are you doing? Because the voice comes, now it's an agent, right? So it's all computer now. You've converted the speech to text. So are you passing the information as data that goes through, or are you passing on the calls as well?
We are passing all the data that we have. So, for example, the call recording, the text that actual transcript from the text, and also the location for quick access, the location, the name of the user. All these things are actually passed to another endpoint, to dispatch endpoint. So, for example, if there is a software for like, so we haven't implemented that part, but if there's a software for like the so it's basically the data that is being sent. So whatever they want to do with the data, they can.
Okay. Did you consider the fact that that's a whole lot of data, and the size of that could be a challenge to the latency problem that Satish was also mentioning? Because when in a natural disaster environment, bandwidth becomes a big challenge, right? It's not as if you'll have perfect 5G kind of services and all of that.
Mm.
So data becomes very, I mean, bandwidth become very crucial.
But that part is only localized to the problem of the disaster itself, right? So, for example, in the call center, we will still have that.
Correct. But
So
when you do the dispatch is what I'm saying.
so the dispatch happens to the service between services itself, right? So that wouldn't be a
Correct.
problem.
But the dispatch, see, if I'm calling in from, let's say, in Nagarkoil, there's no point in me dispatching to Trivandrum, right? I have to dispatch it to Nagarkoil itself, right?
Yeah.
Now in Nagarkoil, there is a data problem. You understand? The
Yeah.
problem is not in Trivandrum. The problem is because the disaster was at Nagarkoil, in a sense.
Yes, got it.
Okay, that's fine. Yeah, Satish, any last questions?
Yeah. So what this application would do, if it were successfully engineered, would be to perhaps shift the bottleneck from the call taker to the decision maker, because some human being has to respond to these urgent pop-ups.
Yes.
Isn't it?
Yes. But
Because
there we have the problem is that not the problem, but the thing is that we can actually that will make it much faster than what already exists.
Yeah, but
So-
that depends on the scalability that you build in. Suppose you have only one dispatch person, and there are about a whole lot of calls coming in, and all of them are saying urgent. So you have 10 pop-ups on this one person's console, right?
But still, that is better than him taking all these calls manually, right? One call after the other, it will still be faster.
What would happen is there'll be 10 call takers, I mean, who are human beings, not automatons. And they will communicate to this boss in some way, maybe intercom or whatever, I don't know. But here, when you say that you are making the system free of human beings.
Not free of human beings.
So you're saying it's not free of human beings.
No, we are actually making it to make the job of human beings faster, or to help. So make them the decision makers instead of actually taking the calls and responding the calls individually. We are making them only the decision maker. So because we can't actually give the entire control to AI itself, that will be another big disaster that is coming as of now. But making the humans as a point of control.
Yeah, so therefore the bottleneck. The
Yes.
moment you say there's a single, I mean, if you want to really make it scalable, then you need to have multiple human beings at that point of the bottleneck. Okay, so I would have said this is useful not for disasters, but for things like suppose there is a service center for TVs. You want to register a complaint. My TV is not working. So there's no urgency. Nobody's going to die because you haven't dispatched anybody. But you capture all the records and get more details. What's happened with the TV? What is wrong? What is it showing? So maybe it can capture all those things without a human intervention. And then when the time comes, the appropriate salesman can call from the field and listen to this, and then take a decision. So for that kind of a purpose where the urgency is not a factor, this may be useful. But if it is really urgent, then things start going. The problem is a disaster is not in one point. It is usually spread across a region, maybe 2 taluks or something, and then the whole load of calls come in. And then if your system fails, you will have a catastrophic situation. You promise that your system will take care of this kind of scalability, but yet when it happens, you're not able to handle it. So also you might want to take a look at software, open source software called Sahana, which is developed in Sri Lanka, which is handling disaster. They've been at it for the last more than 10-15 years now. So they have matured in quite a bit of, if you're looking at disaster. If you're looking at service centers and all that, service requests, then your system can be modified to kind of, I mean, the language still is an issue. Malayalam or any Indian language for that matter is still going to be a problem. So I'll stop here. Thank you very much. Back to you, Arvind.
Hi, Aravind has some network issues, so I'll be taking over. So if everything is done, current team can leave.
Okay. Thank you.
Thank you. So the team members have left, right? So can we move on to the next team?
That's right.
Okay, sure. So the team ID is IIA 0261. The project title is Early Detection of Bovine Mastitis Using Machine Learning. I'll repeat the project ID IIA 0261. I think yes, they're in the waiting room. So shall I admit the participants?
Which college?
Just a second. I'll check and I'll let you know.
Yeah, the college is TKM College of Engineering, Kollam. Sorry for the network issue. I'm back.
Okay.
Yeah. So Darren and Ahmad is here. So they will be presenting their project to the jury. Hi team, good morning. We have the jury here. You can start the presentation. You will be having 12 minutes of presentation time, and a warning will be given to you at 10 minutes. And after that, after the 12 minutes, the judges will take over. It will be Q&A session. So yeah, over to you team. You can start. Thank you.
Yeah, okay, sir. Hello, sir. Am I audible?
Yes, you are.
Good morning, everyone. Myself, Darren. I will be explaining about our project early detection of bovine mastitis using machine learning. We are from TKM College of Engineering from Department of ECE. My project members are Ahmad Rais, Bharat Mohan, and Abdul Rahman J. And we have done our project in collaboration with Veterinary University Thrissur. And the associated faculty members are Dr. Vinod Kumar K from College of Veterinary and Animal Sciences, University Thrissur, and Professor Vishnu D, Professor Shabiras, Professor Anu Assis, Professor Sajina A from TKM College of Engineering. So these are the contents that we will discuss in this presentation. So coming to the introduction, so basically we have developed a device which can detect bovine mastitis in real time and which is easy to use to the farmers. So coming to what is bovine mastitis. Bovine mastitis is a common inflammatory disease which is seen in dairy cows, which is caused mainly by bacteria which affects the udder and which leads to reduced milk production quality. So we have developed a device which detects mastitis in real time by using three parameters: conductivity, TDS, and WBC count of the milk sample. So our device reduces the antibiotic overuse and prevents AMR and promotes sustainable livestock management. And our project also benefits the rural community where farming is a livelihood. So our project also aligns with the UN Sustainable Development Goals, such as zero hunger, good health and well-being, and industry innovation and infrastructure. And this is our problem statement. We have tried to develop a device to solve this problem, that is to detect the bovine mastitis in its early stages. So the current detection methods are very costly and it uses only small, less number of parameters, which results in reduced accuracy, and they need experts to be and the current methods need experts to be done. So we have developed a low-cost device which is easy to use and can be used by farmers alone. So these are the drawbacks of the existing methods. They are having very high cost. They are having complex operation. They are non-portable. They are often time-consuming, and they take several hours, or even they take several weeks to give us the results, and they only take limited parameters. And these are the objectives of our project. We have tried to develop a project uh, which is we have tried to develop a cost-effective solution which enables real-time processing and which is user-friendly and portable, and a easy to use tool for dairy farmers. And talking about the impact of mastitis, the mastitis reduces milk production and weakens animal health. It affects the food safety and causes health risks from contaminated milk, and it also leads to antibiotic residues and harmful bacteria spreading in soil and water. And this is a recent study which was conducted by IIT Roorkee, and in this study it states that bovine mastitis results in 70% loss in milk production. And this is the methodology which we have used. We have collected the data, authentic data from Veterinary University Thrissur. We have used that data to train the model. We have used the YOLO V10 model for detecting the the count of somatic cell from the milk sample. We have also developed our own custom conductivity sensor, and we have also used a TDS sensor, and we have used a Microsoft setup for capturing the images of the milk sample, and we have integrated all these into a 3D design which we have developed using SolidWorks software to which results in the final product. So we have actually developed this project in 2 phases. In the first phase, we had only integrated 2 parameters, that is pH and conductivity, and this is the initial design of our phase 1. And in this design, there was a manual mechanism. As you can see in this right side of the slide, this was the device which we have developed in the phase 1. So in this device, we had to pour the milk in the beaker, and we had to dip the TDS sensor and pH sensor into the milk, which reads the pH and conductivity values of the milk sample, and it predicts whether the particular milk sample is having mastitis or not. And we have further developed this first prototype into our final product by adding our own custom conductivity sensor and by using a Microsoft setup for counting the number of somatic cells from the milk from the cows. So now I am going to talk about the development of our custom conductivity sensor. So we have basically used the voltage divider circuit and a probe and a microcontroller for measuring the conductivity of the milk sample. And this is the conductivity sensor which we have developed, and you can see the real-time values which we have measured using the conductivity sensor. And this is the Microsoft setup which we have added to the initial stage for increasing the accuracy. So initially we were having a 600x magnification by using objective lens of 45x and an eyepiece of 15x. And later we have upgraded into 1500x magnification using a 100x oil immersion lens. And we have implemented we have attached the Raspberry Pi camera to the eyepiece lens for capturing the images, which was taken into the Raspberry Pi for further processing. And these are the images which you have captured using your Microsoft setup. These images are fed into YOLO V10 model for counting the number of WBC cells from the milk sample. So we have collected 252 sample images from 25 slide preparations. And talking about the WBC count machine learning model, we have used YOLO V10 model, and the model was implemented in Raspberry Pi. And these are the results of our machine learning model. and we have received an accuracy of 91.6%. And these are the output of our YOLO-V10 model. And this slide shows the validation data and the prediction data. It shows two batches. Basically, the left figure of each batch shows the validation data, and the right figure in each batch shows the predicted data. And this is our final design. In this final design, we have added a Microsoft setup and our custom conductivity sensor. And basically, this design also consists of an adjusting mechanism where we can adjust the microscope to take good clarity images. And this is a slide inserting session. I will be showing the working video in the later slide, which will explain in detail about the device. So this is a sliding mechanism. So basically, this slide holder holds the slide, which is used to take the images of the milk sample. So our device consists of a milk and stain dispenser unit. So if I am to explain in detail, so this slide holder actually consists of a slide which is inserted during the first phase. And this slide holder which holds the slide moves under this milk and stain dispenser unit, where initially a drop of milk is dropped into the slide inside the slide holder, and after that it is spread evenly using a glass slab, which you can see besides the drying unit. And after that, it moves under the drying unit where the milk smear is dried. And after that, the slide holder moves under the stain dispenser unit where a drop of stain is added. And it again moves to the drying unit where the stain is dried. So now we get a stained milk smear. And this preparation is then taken under the microscope where it adjusts itself to take images of somatic cells from different regions of the prepared milk smear. And these images are then fed into the YOLO-V10 model to count the number of WBC cells in the milk. So this is the TDS and conductivity sensor which we have added in our device. And on the left side, you can see the glass slab which I have mentioned earlier, which is used to spread the milk and stain smear uniformly. And this is the small working video of our prototype. So initially it measures the TDS and conductivity values as you can see. And after that, we have to insert the slide here. So we have to only insert the slide. We have to do nothing. It will just count the milk and it will give the result. So now it is counting the WBC. No, it is dropping the milk. You can see milk drop command in the LCD display. And you can see it is drying the milk. And you can see it is dropping the stain. And the stain is dropped and the stain is dried now. And now the slide holder moves under the microscope where it takes the images, and now it displays the number of somatic cells and it predicts whether the cow is having clinical mastitis or subclinical mastitis. So this is our phase 1 prototype and phase 2 prototype. And this is a model comparison between phase 1 and phase 2. Our phase 1 was having only 2 parameters, and our phase 3 was having 3 parameters. And we have made our final prototype a fully automatic system, and we have improved the accuracy. And as a future scope, we are aiming to improve the AI model, and we are also trying to implement an automated sample collection. And as a conclusion, we have developed a real-time mastitis detection machine, which is easy to use to the farmers. We have to only insert a slide at the beginning. It will just it will just predict whether the cow is having subclinical or clinical mastitis. I have
Are you going to say something, Darren? Stop.
I think there is a network issue
Network
on
issue.
Darren's side. Does anybody else from the team want to take over? Yeah, Darren, you can continue. Yes, Darren.
Can you hear us, Darren?
Does anybody else on the team want to take over? Muhammad, Abdul Rahman, anyone?
If you're speaking on mute because we can't hear you.
hello, sir. Am I audible?
Yes.
Hello, sir.
Yes, who's this? We can't hear
Yeah,
you.
okay, sir. Sorry, sir. The current was not put here.
Okay.
Is this Darren? I'm not sure. We are not
Shall I
sure
continue?
who's this. Yes, Darren.
Yeah. Okay.
Continue.
Yeah, shall I continue my presentation, sir?
Yes, please, you can continue.
Yeah, okay, sir. Yeah. So I was into the conclusion. So in the first day, I forgot to mention two stages of mastitis. The mastitis has two stages: clinical and subclinical. Subclinical occurs in the early stage, and if it is not diagnosed early, it will affect the cows. So our device aims to identify subclinical mastitis in these early stages. Yeah, sir. And these are the references which we have referred to, and that's it, sir. Thank you.
Thank you, Darren. I think there's a bandwidth issue. You can stop sharing so that you can save the bandwidth. And over to the judges for Q&A.
Satish, you understand?
Yeah. So thanks, Darren, for the presentation. It is good to see that this is a project that goes down to the grassroots of our society with milk farmers and producers. So my first question is, your testing machine, where is it located? In the lab, in the dairy, or somewhere else?
Sir.
I think there is a network issue again with Darren's end. Does anybody else from the team want to take the question? Yeah, Darren rejoined. Darren, you can unmute and start.
Yeah, hello, sir.
Yeah. So turn off your video.
Yeah,
Otherwise,
okay,
you
sir.
lose bandwidth.
Okay,
Okay.
sir.
Did you hear the question?
Yeah, yes, sir. Our device is a portable device. We
No,
can use it
but for
anywhere.
actual practical use, where do you propose to situate it? Is it in the dairy or is it
Yeah, in the
somewhere else?
diaries.
Okay, if it's in the dairy, there's a problem. The problem is that suppose a cow has mastitis.
Yeah. Okay.
That cow's milk is supplied to the local society.
Ah,
Together with all other cows, it is mixed, and the
yeah.
mixture is brought to the dairy.
Yeah.
Now, if you test it, you might find a positive, but you have no clue where is it come, which cow it is coming from.
Actually, we are not implementing in such diaries. We are giving the device where individual cows are treated. Like in each house, a device should be there.
Oh my goodness, that is overkill, no? To have a testing device like this. Okay, then what are you that staining? What kind of staining are you using,
Yeah,
and
we are
why?
using uh, 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 I forgot the name actually.
Is it gram staining? Normally, staining is used to separate two kinds of bacteria, gram positive and gram negative.
Actually, we are using the staining to remove the fat content of the milk.
What? Stain has nothing to do with the fat content.
Yeah, and
See, the
to
concept behind staining is that there are two types of bacteria. One is pathogens, which actually cause disease. Other is the
yeah,
normal microflora. And you want to count the pathogens because they are the ones who are actually causing the disease. So staining allows us to separate the two into two categories. There are two dyes used. So after the slide is dried, you find the two colors in the output. But you seem to be counting everything. So what are you
actually
actually counting?
we are counting the number of somatic cells.
What is the somatic cell?
Actually, the number of somatic cells in a normal cow's milk is very lesser when compared to an affected cow.
No, that is not a somatic cell. A somatic cell is a normal cell. If you are detecting early mastitis, that should be shown by one particular type of cell. See, mastitis is a generic disease caused by a bunch of bacteria, starting with Staphylococcus aureus, and even E. coli sometimes is a pathogen. And now, any technique that counts everything is of no use because even the purest of milk will have bacteria in it. That's not a bad thing. But if you have pathogens in milk, then you have a problem. So you ought to be actually counting the pathogens and not all cells. If you count all cells, you get a fairly meaningless number. So I'm not able to understand. Can you explain how it is?
Yeah, okay, sir. So when we were into this project, we had a little study about this the condition, and in this study, we were able to understand that when the cow is affected by mastitis in its early stages, uh, the number of somatic cells in the milk increases. So rather than the which is seen in the normal cows. So if you
Okay.
cow,
Let's
so
assume
if
that's the case. Let's
yeah,
assume
okay.
that's the case. And you are staining the milk sample. So hopefully that will allow you to count all cells in the milk, or is it only so-called somatic cells?
Actually, only somatic cells, sir.
How does that staining work? I've never heard of a staining that will only kind of stain one particular type of cell when there are actually a number of different types in the milk. Can you tell me what staining it is?
Yes, sir. Actually, we are using uh,
Okay,
sir,
so forget it if you're not able to answer
Newman
it.
stain, sir.
What?
Newman stain.
What is the actual stain used?
Newman stain.
No, that's the name of the technology. But what is the actual the color? Is it like methyl violet or
Methyl blue.
phenolphthalein? Methyl blue.
Yeah.
Okay, so what does that convey? What so you're saying that methyl blue only colors malignant cells or what you call as somatic cells. So you are doing a count of that?
Yeah, yes, sir. We are doing the count of somatics.
So what does it indicate? Are you comparing with any standard, saying that beyond this point it is suspected mastitis?
Yeah, yes, sir.
What is that threshold?
About 2 lakh.
2 lakhs.
Yeah, yes, sir.
Well,
2
that
lakhs per milliliter.
okay. So where in your program are you extrapolating from the count that you get from the stained slide to this number? Because stain is not 1 ml. Stain is much less than that. So how do
Actually,
you
we
check
have
whether? Sorry.
we have only we have calibrated the milk dispensing unit to drop exactly 1 milliliter.
1 milliliter will run all over the slide. You don't
No,
need
so
1 milliliter. You only need
0.01 milliliter.
part of
Sorry, sir.
sorry?
0.01 milliliter.
Oh, 0.01 milliliter.
Yeah,
Okay.
we have it.
Right. So I also do not understand where you're testing the pH, because according to you, the pH is another indicator.
Yeah, okay, sir. So we have used all pH as a parameter only in our first device, and it was pretty unstable. The
What
pH
is
meter which we
unstable?
have taken,
The device is unstable or the indicator is unstable?
the indicator was unstable. So in the final model, we decided to remove the pH, and we developed our own custom conductivity sensor.
But whatever gave you the idea that pH is an unstable indicator of, anyway, let's not go into that, but pH is a well documented indicator of early mastitis.
Yeah, sir. But the one problem which we encountered was that the pH sensor needed to be calibrated.
So it's a sensor problem, not a pH problem.
Yeah, okay,
Okay.
sir. Sorry, sir.
There are various ways of anyway. Let's forget that. So you have ignored pH now, and you're only concentrating on the cells.
Yes, sir.
Anyway, I'll stop here. I have a bunch of other questions, but I'll stop here and over to Varghese.
Right. So you said you use the YOLO V10 to measure the number of somatic cells, right?
Yes, sir.
And you said you run that on if I'm not mistaken, a small board. So what size is that model, and how accurately does it run? Because I thought it would need a fairly high level of computation to run. So how do you ensure that there is enough computing power to get the right answers?
Yeah, okay, sir. So when we looked into the YOLO V10 model, it had varieties of model like YOLO V10B, YOLO V10M, YOLO V10N. We have particularly used YOLO V10N model, which is suitable to be implemented in Raspberry Pi like devices, where resource is a constraint.
So does that reduce the efficiency in any way? What does study show? For
Yeah, yes,
example, if I run it in a cluster versus running it on a Raspberry Pi, what would be the accuracy differences?
yeah, sir. The accuracy will be a bit less, up to 2 to 3%.
That's all.
But I think, sir, we have only used a YOLO V10N model since we had to make it as a portable device. We have not used the other models to compare.
Wow.
So
And to the question that was asked, in terms of the counts, how do you ensure that the accuracy? Because at the end of the day, everything that you do is based on the total number of count in a sense, right?
yes, sir.
So how do you ensure? Do you have a human in the loop somewhere to kind of verify and validate, the accuracy of the results? How do you make sure that you are doing things right?
Uh, Actually, we have trained our model to predict the results, right? So during the training process, we can see that this is 91% accurate. So we can say that it is accurate, right? we don't actually need a human to.
Okay. So what was the training? How many samples did you use in your training?
Actually, we had 252 original samples. We had
Yeah,
done,
very small.
yeah,
Go
yes, sir.
ahead.
We have increased the sample to 3000 by using various data processing methods.
But that's synthetic data, you're saying.
Yeah, yes, sir. So the
Okay.
authentic samples were very hard to find because we were unable to find. It was very hard to find the cows which are having mastitis.
Right.
So we had to take this much number of samples and we had to replicate that samples.
Okay. Well done. Thank you. So
Yeah, so one last question. I think personally, this is my personal opinion, that you're putting too much of faith in your model. If you're saying that you will do a bunch of initial tests and then let the model continue without any supervision, which is what Varghese was asking, that is very dangerous.
Yeah.
We always need to have some kind of a backup, at least random checking or outlier checking. Outlier is when you have some samples which are very, very, way high or way low. Then you need to go and check why it is so low or so high, or random
Yeah.
checking. You choose a random every day. You choose some random samples and cross check. Otherwise, the faith in only model, at least at the current phase of AI, may be misplaced. So that is a piece of advice that I can give you. Thanks for your presentation. Back to you,
Okay, sir.
Madam.
Thank you, sir, for the advice. I think it is a we haven't thought that much.
Sure. Thank you, Jory. I think there's no more questions from anyone. Okay. Thank you, team. Thank you for presenting. You can leave the meeting right now. Thank you.
Thanks.
So I think, yeah, the team has left, right? Okay.
Just a minute. I think the other team is already here.
Yeah, you can just ask them to join the waiting room again. He's not now here, please. So the next project is from the next project is from Federal Institute of Science and Technology. Akhil Babu will be presenting their project titled Code Guard. The project ID is IAA 0282. 0282. So, thank you. I will be admitting that. Please hold on. The team is joining. I have admitted them.
I added them, but I think they didn't join for some reason.
Yeah, they left again, and I mean they are not joined here. Susmin, can you please coordinate with that?
Yeah, I'll call them up and I'll ask them to join.
Sure, please, thank you. Actually, they were in the waiting room. Yeah, he's in the waiting room. Yeah, Akhil Babu has joined. Good afternoon, Akhil. Akhil, you're on mute. Hello. Akhil, are you saying something? We cannot hear you right now. I think there is a network issue, Akhil. Can you please try again? Is it only for me or for others also? Susmin?
Yeah, I can't hear.
Akhil, we cannot hear you. Do you want to try again by leaving and joining again? Do you want to try that?
Hello. Hello, can you hear me?
Yeah, now it's clear. Yeah.
Okay.
So Akhil, we have the jury here. You can start your presentation. You will be having 12 minutes to present. After 10 minutes, you will be given a warning. And after the 12 minutes are up, it will be open for Q&A. Are you good to go? Akhil,
Yes.
yeah, I think your voice is again. I think your voice. I mean, there's a network issue there. Your voice is breaking up.
Hello. Abhiraj.
Akhil, does anybody else on your team wants to take over?
Hello. Can you hear me?
Yeah, now it's okay. Yeah, it's
Okay. Thank you. I'm the only person in my team.
sure, sure. Yeah, you can start presentations. Thank you.
Okay.
Thank you, joining.
Thank you.
Akhil, if there's a network issue, you can turn off your video to preserve the bandwidth. It's okay.
Okay, fine. Yeah. One second, sir. Hmm? So can you see my slides?
No, yeah, now we can see your slides. Yeah, you can start.
Okay. So good morning, good afternoon, sir. My name is Akhil Babu MK. I'm completing my BTech in Computer Science and Engineering at FISAT with a CGPA of 8.92 and also an undergraduate research in Cognitive Computing Research Center. So let me explain project. So imagine this scenario. It's 3 a.m. Your application is live and serving thousands of users, and suddenly you discover that in a single line of vulnerable code has exposed 147 million user records, just like what happened to Equifax in 2017. A simple SQL injection that could have been caught and automatically before deployment. So there are multiple real-world examples for these types of attacks, like TikTok XSS attacks in 2020 and British Airways data breach in 2018, and as I said earlier, Equifax SQL injection attack in 2017. So software applications are frequently targeting of such vulnerabilities like SQL XSS, ACSRF, and many different types of vulnerabilities. So our main problem statement is, despite the rising number of security breaches, developers struggle to secure their code base due to manual security audits are slow and expensive and make it hard for developers to find and fix vulnerability in time. And security audits are often conducted after their project completion or even post-deployment, make it difficult and expensive to identify and fix vulnerabilities. So attackers exploit security gaps faster than they are patched or increasing the risk. And another problem is that traditional security rules lack automation, requiring expert intervention also. So what we need is that a fully automated AI-powered security solution to detect, fix, and integrate security directly into the development workflow. So today I'm here to present CodeGuard, an AI-powered security guardian that ensure these types of nightmare never become your reality. So our objective is to develop an advanced vulnerability detection tool which can able to catch OWASP's top 10 vulnerabilities with rule-trained analysis and along with the machine learning process. And Along with that, a smart patching like fix flows instantly using AI-generated patches from LLMs. And we can able to integrate GitHub so that we can able to import and scan real-time through GitHub projects. And we integrated CI for continuous integration for the pull and push request. So our CodeGuard is a cutting-edge security platform to enhance code-based protection through intelligent vulnerability detection and AI-driven remediation. The system integrates seamlessly with the GitHub, allowing users to scan code bases for critical vulnerabilities, including OWASP top-10 risks like XSS and SQL injection, as I said earlier. CodeGuard employs an hybrid approach, an advanced SAST, also known as Static Application Security tool, developed in-house that combines trained analysis of abstract syntax tree nodes, like a source-to-sink tracking, with a rule-based detection. For further improvement of accuracy, a Vertweg plus LSTM model is developed to detect OWASP top 10 vulnerabilities. Upon identifying these types of vulnerabilities, the platform leverages a large language model to generate precise context-aware patches and enable one-click fix with automated GitHub commits. Additionally, Code had integrated CI pipeline to scan code changes during the push and pull request, flagging vulnerability in real time. By seamlessly integrating advanced detection and automation remediation, CodeGuard empowers developers to secure the code base efficiently. So during the development cycle of this project, we are achieved 4 different things. So as I said, as we know that to develop such a production-ready application, we need a real-time data set to develop an LSTM-based machine learning model. So I go through every data set that are available in the internet, but I identify that they are not ready for production ready or production level, or they are just snippet of these types of vulnerabilities. We cannot able to accurately predict these types of data set. For that, we developed a comprehensive data set from GitHub, and proudly we can say that from online available data set, our data set is biggest size in size and production ready format. And secondly, our XSS model implemented achieve comparable accuracy with a significant enhanced processing speed compared to the latest paper result in engineering science direct. And also, we know that for a classification model, we can only say whether a file or whether a code has vulnerability or not. We cannot able to pinpoint the location of the vulnerability, where it actually there and what type of vulnerability is that. For that, we developed a method capable of pinpointing the vulnerability location in code using machine learning and able to productize it also. So this is basically the architecture of our work. So when a user come to your platform, we authorize with the GitHub application, then he can see different projects that are available in her GitHub. Then after he select one of the GitHub application that he need to scan for these types of vulnerabilities, he can configure whether he want ML or not. Then after that, we need send it to an analyze engineer. In the analyze engineer, we already set a SAST plus machine learning powered engine is there. We can able to combinedly process the code and generate a detailed SARIF report about our vulnerabilities in a code base. And this SARIF report, and along with the code, we send it into a large language model to efficiently identify and fix those vulnerabilities. So LLM can able to understand effectively and generate Git diff like code like before the vulnerability and after the vulnerability, and the developers can able to see these types of able to compare this change, able to push these changes indirectly to the GitHub. And also you can you don't want to come to a platform and entirely scan the project and fix this vulnerability. You can able to so suppose you have a project and you just pushing something into the GitHub. We set a CI and where a GitHub action where a project where model is there. You can directly or it will trigger automatically when a push happen, and on that there is an issue will generate it. User can able to know what type of vulnerability there and fix it. Complete code and this days
Akhil, you might want to
time.
switch off
Can I
your
go further?
video because you're breaking up.
One second.
Yeah.
One second, sir. Hello, can you hear me?
Yeah, please go.
Oh. Okay. Line. Then after that, this is. Can I show the video of my project? Then can I show explain what is happening inside the SAST and machine learning model, which you prefer first?
Sure, sure. Yeah.
Video, sir.
Yeah, go ahead.
Okay. Can you see the video, sir?
Actually, no, you are sharing the
Slide.
presentation screen. Yes.
Oh, okay, one second.
I have a suggestion, Varghese sir. I think we can also go on video mute so that it will save his bandwidth, download bandwidth also.
Oh, okay. How can I do that?
Yeah, Akhil, you can please proceed.
Oh, okay. So can you see that?
Yes, please. Your browser window is open.
Oh, okay. So
Hi, everyone. Welcome
is it playing, sir?
Yes, yes, please proceed.
to
Yes.
CodeGuard, smart security platform that protects your code on you.
The volume is a little low. Can you please increase the volume?
Oh, okay.
Its features,
Is it okay?
the problem it solves, its architecture, and a quick demo of how it works. Let's get started. As developers, we face a big challenge, keeping our code safe from attacks like cross-site scripting and SQL injection. These vulnerabilities can lead to data breaches or financial losses. Manual code
I will just skip for this. I already explained these things. I will just keep it, sir. Okay.
checks abilities. Git uses a custom structure design with a React.js frontend for a smooth user experience and a Flask backend for handling requests. The system connects to GitHub via API generates. Now let's connect to GitHub button to start. In this demo, you'll see how it works step by step. Homepage. This is the CodeGuard homepage. It's clean and simple with a connect to GitHub button to start. The page highlights features like advanced security and real-time scanning. GitHub login. Here, we log in using GitHub OAuth. It's secure and quick, linking your repositories to CodeGuard. Repository selection. Once logged in, you see your GitHub repositories. We'll pick one to scan for vulnerabilities. Scanning process. CodeGuard starts scanning the code. It uses the SAST tool and machine learning models to check for issues like XSS or SQL injection. This takes just a few seconds. Results view. Here's the result. CodeGuard lists any vulnerabilities found, like an unsafe input in a JavaScript file. It shows the exact line and explains the issue clearly. Fix suggestions. For each issue, CodeGuard suggests a fix, like adding input sanitization. You can review the suggestion and apply it with one click, which creates a commit in your repository. CI/CD integration. Finally, we see CodeGuard working with a pull request. It scans new code changes and flags any issues, keeping your project secure as you work. It makes securing your code simple, fast, and smart. By combining advanced detection, AI fixes, and GitHub integration, it helps developers stay one step ahead of vulnerabilities. Thanks for watching, and try CodeGuard to protect your projects today.
Hello, sir. Can you hear me?
Yes.
Can I complete repeat resume my presentation?
Yeah, go ahead.
Okay. So this is the SAST working actually. So basically what we are doing is that you actually taking the source code and completely convert it into a AST using some tree sitter like modules, and it can able to completely passing like this right side format. Then after that first as a first stage we are performing like a rule loading and compilation. So we have a set of rules like as I said, there is a source in there is a source. So this is actually where the vulnerable code which were the vulnerability code that enter into the file program, and sync is where the vulnerability will be executed. So between the file path, which we know that this is the tainted path. So we have set of source and sync and set of rules are there, and based on the rules the rules are also compiled into a specific format. Then after that, basic pattern matching process will be conducted as an initial process. For example, eval of $x, we will convert it into an AST, and also the code will be also converted to AST, and basically a pattern matching will be happen. And if there is some vulnerability found, we can say that there is a vulnerability there. But this is the most of the AST will be like rule-based loading is happening with. For enhancing further, we are using a tained analysis flow also there, which means we are first of all collecting source, we are identifying the source, then so here in the code request.get of username, here's the source, and it will send it to a user input, and select star from user where it will send it to a query. Then after that, the query will be executed in a db.execute. So in between the flow, there is no sanitization happening between the user input, so that we can ensure that sometimes some user can maliciously send some request and able to execute in a db or some database part, so it will be make vulnerable. And tained analysis with sanitization sometimes happen in some codes. So we can see that sanitize SQL of user input. In between the sanitization happen, we don't want to project it as a vulnerability. So here is also handled this by. So this is basically what happened inside a SAST based part. Then in order to increase the accuracy of this prediction, we enhanced it with UR2Vec plus LSTM. First of all, we collected large code base from GitHub and trained a word-to-vec model so that we can able to generate vectors semantically meaning. After that, we trained an LSTM model. So expand code guard ML capability and use word-to-vec to embed code token into semantic vector space and apply LSTM to analyze the token sequence and classify vulnerability in a fine-grained tokens. But one of the problem that I said earlier is that LSTM can only predict whether it has vulnerability or not, just a probability for an entire file. But we need to have a specific line where the vulnerability are exist actually. For that, we developed a method like a context window or a sliding window approach. One second. So this vectorized the tokens and send it to LSTM. Then after that, we will classify whether it has a vulnerability or not, be predicting the probability. So can you hear me?
Yes.
Okay. So I will show you how actually the sliding window approach work. So we 1 second, I will show you. Stop sharing the screen.
Just a moment. I'm really sorry to interrupt.
Okay.
Varghese Cherian and Sudesh Babu, with your permission, we can go ahead. The time has been wrapped up.
Oh.
Yeah, I would suggest if you can wrap up probably in a minute or so.
Oh, okay, sir. I will. So the context window is working like that. Okay, I will explain. Okay, there is a 5 token like or is window is there. Then window will be go through each and every line of the code, and there is a focus token is also there, and able to, based on the focus token and the context window, it can able to predict whether there is vulnerability exist in that line or also. So that it's just one step moving window, so that we can able to capture the meaning also from for the LSTM model. So again, this is the result of the LSTM plus LSTM like left side you can see the GitHub code.
Please share your screen again.
Oh, 1 second, sir. Sir, you can see, right?
You can go ahead. Thank you.
Okay. So this is the result of our prediction. Left side, you can see the GitHub file which has XSS vulnerability, and our model predict the red mark as these lines have the XSS vulnerability, and other green shows there is no vulnerability, and the comment shows like the gray color. So this is the enhanced architecture of the LLM. And we are also trained specifically for XSS vulnerability for CRN plus LSTM architecture. And this is working behind that. So we're fine tuning with Optuna workflow for identifying the parameters efficiently. This is the accuracy table and everything. So can I skip? Okay. This is what we are seeing the project video. This is abstract syntax to basic diagram. And basically initial study we just looking for LLM only based analysis, but the accuracy is not that correct. This is based, but they can able to predict it. But okay, but we need to have something tool has that. So this is the initial study data, sir. So this is that code can achieve application security through its integration of custom SAST in machine learning access detection and web top 10 vulnerabilities. The implementation AST-based pattern matching combined with the LSTM neural network delivers superior vulnerability detection accuracy while reducing false positive. So thank you, sir.
Thank you, Akhil. Over to the judges.
Akhil, there are already a lot of tools, including the copilots, the cursors of the world that do this. So what makes yours very different and very unique?
So as a SaaS application like SemGrep, code SemGrep like tools, they are just a set of, they're making a database, and there are lots of CVV are there inside the database. So these are not completely able to predict whether these types of vulnerability, sometimes some new vulnerabilities are there. Every time a new CVV is identifying there also. So they can predict pretty well, but they cannot able to efficiently predict it. And also they are a separate tool, and they cannot able to integrate directly to a complete web project or during these types of actual development workflow. And CodeQL, one of the GitHub vulnerability detection tool, and actually they are right now actually implementing machine learning behind the vulnerability detection. Actually, they are also create a query language like QL language inside code base, and they are developed a large code base for identifying vulnerabilities, and they are right now actually implementing these types of machine learning, sir. So I think our tool can able to predict machine learning accurately. Our machine learning model accurately well performed, and for the prototype and everything, I think it's a better one, sir. That's
See, there are two types of tools, right? There are the SaaS tools and the high-end ones like Snyk, Veracode, all of that are very, very, very standard tools in large enterprises.
Yes.
That's on one side. Then you also can club it with, tools like, for example, SonarQube, which also finds vulnerabilities and helps specifically where the vulnerability is, what the vulnerability and so on. And then you have the copilots of the world, which also does a lot of this that you're talking about.
But they are not providing actual fixes right now to projects.
They are. Copilot will give you exactly where, what fix and where.
I think Copilot is not trained for this identifying these types of complete vulnerabilities, sir.
There is a Copilot review module that does that. So that is why I'm kind of still confused as to where this fits in. That's fine. Satish. Satish, if you're speaking, you're on mute. Okay. By the time Satish, reconnects, see, one of the big challenges with a large code base is the number of tokens.
Yes.
Most LLMs get, very, 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 I would say, confused when the number of tokens increases.
Yes.
There are very few LLMs that can manage large number of tokens. Yes. So when you're giving it a large project, small projects works fine. But when you're giving it large projects, what do you think would become the challenge? One is the cost, obviously, but what else?
So the
And
challenge.
how do you kind of manage that? Because
Okay.
in most organizations, that is a big challenge.
So the part is that initial process is like SAST plus machine learning based vulnerability detection. So once this process is completed, we generating a comprehensive SARIF report. So they can, so in the SARIF report, actually the severity level and the where the file, which file and which line, which code part has these type of vulnerabilities and everything. So basically, we know where and which all are the files that have these types of vulnerabilities. So we don't need to provide the LLM have the complete code for the context. We just need to provide the files and the corresponding dependency files and the relationship also, so that we can able to reduce the number of tokens. And also, if we can able to further increase the accuracy by creating a knowledge graph. So basically, the complete code base will be converted into a knowledge graph. They can able to track the graph through which all are the files and what are the dependencies and exist there. So it's not implemented in knowledge graph implemented. We are logically thinking about that, how to create a knowledge graph efficiently so that we can reduce we can make the LLM understand effectively what the code base and everything, etc.
Yeah, so this is Satish. Like Varghese points out, I don't see any need for such a tool because coding and IDs and code review and plugins have been around for 20 plus years. The OWASP top 10 has been around for about 15 to 20 years. There have been so many tools that programmers have been using over the last 20 years that does exactly pull the rules from maybe OWASP or other sources, or even your company sources for additional security, and then run code reviews for every line of code. That is happening. It has been happening for the last 20 years at least. So what is new and why do you want to bother with an LLM for this?
So sorry, sir. Hello?
Yep.
Can you please repeat the last portion?
No, I was saying that I don't see any need for this. The programmers, no, I started programming in about 30 years back.
Okay.
So from then, OWASP was around. It's an open source bunch of vulnerabilities. It has been around for 15 plus years at least, and people have been coding all this while. They haven't needed any LLM to kind of scan through these things and do a code review on every line of code. Sanitization of code. You're not mentioned sanitization. It's a very important step.
Already I said about the SAST part sanitization is happening. Are LLM able to generate the sanitization?
LLM is not required for that. Programs have been doing sanitization for ages. So you are proposing a very complicated solution for a simple problem, which has been, solved by engineers, by coders, developers all these years. So it gives the impression, it may not be intentional, but it gives the impression that you somehow want to bring in AI into this, whereas it is actually not required. AI is not required for this particular exercise because we have been doing the same thing without AI for the last so many years.
Yes, sir. For a large enterprise, sometimes it's not needed, sir. But as we know that
I'm talking about open source programmers, one person programming.
Oh, okay. So
that person can do it without any AI because he doesn't have time to bring in AI
for a large enterprise
application,
applications, how you can able to manage for manual intervention every time? So it's very difficult, right? Without an automated tool.
No, there is no. This is automatic. Plugin, a VS Code or a NetBeans plugin for this purpose. You just download, install it, and then it will flag as you code. It will flag. What is red and what is yellow and so on.
Still, they are using SaaS-based applications. They are not using any LLM.
No, this is not SaaS. This is a local plugin. Varghese will be able to kind of provide more details on that. But I'm just saying that programmers have been doing this without any language models for so many years. No, there are places where language models are useful, but this is not one of them, as far as I can make up. Varghese, what do you think?
Yeah, that was my point as well. For many, if you look at Copilot, Copilot has a code review module that actually uses a lot of this, including the next best answer. You'll get vulnerabilities, online and all of that. So, even if you want to go there, there are tools there. But to your point, Satish, yes, there are SaaS tools, there are DaaS tools that does a lot of this today, which without any AI at all. Maybe some have machine learning built in, but they all work, and they are plugins into the IDE. So it's all integrated, and there are open source tools as well. So it's not that it's so I think you need to really identify where the difference is, because right now that doesn't seem to be coming through.
Right. It's a good attempt, but you have to precisely demonstrate without AI this would not have been possible, and with this AI it is possible. If such a kind of a thing is there, then it will be clearer for us to judge. So thanks very much, and back to you, Arvind.
Thank you, judges. Thank you for joining today. You can please leave this meeting. Thank you.
Okay.
And Subin, if you're online, can you please stop the YouTube live streaming also, and please confirm here.
Yeah.
Yeah. So what